You can solve simultaneous linear equations algebraically, and there's a couple of ways that you can do that. But it's important to also understand that the solution to any simultaneous linear equation can be solved graphically. Now, what do I mean by this? Well, here we have one rule, y equals 2x minus 1, and we can graph that rule. Now, there's a few ways you could do it. You could set up a table of values and say when x is a range of things, what would y be? You can also graph it by using the y equals mx plus b method, where we know already that the coefficient of x, the number in front of the x, which in this case is 2, will be the gradient of the line, and the number that's tacked onto the end, which in this case is minus 1, will be the y-intercept. Let's use that method. We know it goes through minus 1 on the y-axis, and it has a gradient of 2, which is going in this direction. Remember, positive gradients go this way, negative ones go that way. And we can basically build that gradient by going across 1 and up 2 to find another point on that line, across 1 and up 2. Obviously, if you've got graph paper, this is much easier, across 1 and up 2. But even on this fairly rough drawing that I have here that's just freehand, we can graph that line quite confidently using that method. This is y equals 2x minus 1. Okay, if you'd use this method to do it, you'd have some points and you'd draw them up with your ruler just the same. All right, what about this other one? Y equals minus x plus 2. Well, this one has a gradient of minus 1 because the number in front of the x just has a minus there. That means minus 1. So a gradient of minus 1, negative gradients go this way, and 1 means the rise over the run. We've got one box up and down for every one box across. So we need to just look at the y-intercept here, which is 2, find that point as your starting point, and then build your gradient going across one box and up one box, across one and up one. And as you go, you'll see all of the points that it goes through, and you can go ahead and graph this. So now we can label that one y equals minus x plus 2. Now, each one of these is a rule, if you like, and there are an infinite number of x and y values that satisfy this rule. All of those values have pairs. If x is this, y would be that. If x is this, y would be that. And all of those pairs are the infinite number of dots that are on this line. Okay? It's only a line because there's an infinite number of individual points. Okay? And infinite because it goes on forever this way and that way. And also infinite because you can divide up any interval into an infinite number of tiny, tiny bits. So we have all of the solutions, if you like, to this rule sitting on that line, and all of the solutions to this rule sitting on this line. So this point right here, which looks very much like the point 1, 1, is the solution to the simultaneous equation of trying to solve both of these rules at the same time. In other words, if x is 1, y will be 1, and that should be a solution for both of these lines. Now, it's nice and easy to read it off the graph, especially if it's beautifully drawn on graph paper, and you can actually just verify that that looks like the solution. But how do you check? How do you check if it really is 1? It's not just 0.995 or something that's really close. All right, well, this is how you do it. You first sub it into this one. Let's call this one equation 1. Equation 1, and this could be equation 2. So let's take another colour. Just looking at equation 1, what we need to do is we'll write the equation down and check x equals 1, y equals 1. All right, now the way to do this, treat the left-hand side and the right-hand side of the equation separately. Now the left-hand side is just y, isn't it? So if we substitute in the value of y that we think might be the solution, we say left-hand side equals y, which is 1. All right, what's the right-hand side? Well, the right-hand side is 2x minus 1, which is, if we sub in 1 for x, then we've got 2 lots of 1, that's 2, minus 1, that's 1. So we get 1. So the left-hand side was 1 and the right-hand side was 1, well, they're equal. So we say left-hand side equals right-hand side. Therefore, 1, 1 is a solution. That's for the first equation. Same thing for the second equation. In equation 2, we have y equals minus x plus 2, okay? If we want to check the point 1, 1, then we just write down the left-hand side equals y, and that's 1. And the right-hand side, well, that's minus x plus 2. And if we sub in a 1 for that x, then we're going to have minus 1 plus 2, which gives you 1. So, left-hand side equals right-hand side. Therefore, we have found that that point 1, 1 really is the solution here. So, 2 steps. The first is you can graph a line, or you can be given a graph where it's already done for you, and you can read off a solution from the graph, but you can also algebraically then check that it actually is the correct solution. Now, for your Year 12 Standard Maths course, the way you're going to use simultaneous linear equations quite a lot of the time is to apply them to real-life situations. So here you've got some kind of situation where somebody's got a number of cards, perhaps they're a card manufacturer, and we've got a number of cards here, we've got cost on the y-axis, and we've got 2 linear equations that describe the revenue, which is the amount of money that this person's making by selling their cards, and the cost of actually making the cards. Now, it sort of makes sense that these 2 lines are going to cross over at some point, because imagine if you're a card manufacturer, it's going to cost you quite a lot to make just one card, and yet you're not going to sell it for very much. So when you're not making many cards, for example, it looks like when you're making less than 15 cards here, the cost actually is higher than the revenue. So it's costing you more money to make those cards than it is from what you're making out of them. So you really have to sell at least 15 cards before you start to make any profit whatsoever. Now you could also look at the distance between these 2 lines at any one point and say that that would actually be the profit, wouldn't it? Because if it's cost you this much to make, but you've made this much, then this is your profit. So the more cards you sell, the bigger that profit margin is going to get. Now, you can read quite a lot of things off a chart like this. Obviously, mine's a bit rough, I've just drawn it on the board. But looking for those points of interest where the lines cross over is generally where you'll be looking for the answers to your questions.